Hey, okay. We're starting chapter 3 of calculus, which is our last unit. Um, and this chapter is about derivatives, and derivatives is really just another name for slope of a function. It's the same thing that we've been doing for a while now. Um, Except there's one new notation. Actually, there are several new notations for slope that we're going to use. Here's one of them, f prime of x. Um, Before we've been doing stuff saying find the slope of a function at the point x equals a. And so then you'd end up with answers that have a's in it. But now the idea is that we're going to keep that a and x in our limit formula. And so we get some slope function in terms of x instead of in terms of a. And the new notation would be this for the slope of a function at whatever x value I want. So it looks just like a function, except it's got this prime that's called f prime of x, is what you would say. Right? So let's look at this problem here so you can kind of see how this gets used. Using the limit definition of derivative, which is really just slope, differentiate f of x equals x cubed. And differentiate means take the derivative of or find the slope of. So when I say differentiate f of x equals x cubed, that means find the derivative, find the slope. And that, the slope formula is this, limit as h goes to 0 of f of, now instead of a, we're going to say x plus h minus, and instead of a again, I'm going to do it in terms of x, all over h. And so now it's a problem just like last chapter. And so if I work this out, we've got limit as h goes to 0 of x plus h cubed minus x cubed all over h. And if you work out the x plus h cubed part, you're going to end up with this. Now you could work out the x plus h cubed by doing, it's x cubed plus something x squared h plus something x h squared plus something h cubed. And then these terms right here are 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3, if you remember that idea of the binomial theorem. And all that works out to, let's see, 1x cubed plus 3x squared h plus 3xh squared plus 1h cubed. So that's this part here. And then this part, the minus x cubed, just stays the same. So minus x cubed, and then all over h. And now if you look at it, we got 1x cubed here and negative x cubed there. And then I can factor out an h from the remaining terms on top. 3xh plus h squared all over h, and then these guys cancel. And at this point I can plug in the 0, so this guy turns into 0 and that guy turns into 0, and I'm left with 3x squared. So if my function is x cubed, and I wanted to figure out the slope when x was like, I don't know, 2, then I'm going to do f prime of 2 and plug in 3 times 2 squared and get 12, and that means that the slope when x is 2 is 12. So for example, f prime 2 equals 3 times 2 squared equals 12. That means slope of f at 2 is 12 at x equals 2. And you can even think of that as, you could also start calling it the derivative of f at x equals 2 is 12. Okay. So when does the derivative equal 0? So let's set the derivative equal to 0. We know the derivative, the slope function, is 3x squared. So that means that x squared is 0, and that only happens when x is 0. And so what does that mean in terms of the graph? Well, if the slope is 0, then the graph has a horizontal tangent right there. So since slope equals 0 at x equals 0, f has a horizontal tangent there at x equals 0. Okay, so let's graph the two things. X cubed. So x cubed goes through 0, 0. When x is 1, it equals 1. When x is 2, it equals 8, so it'd be way up here somewhere. And then it does the same thing on the negative side here in quadrant 3. So it'd be way down here somewhere. So our graph is going to do something like this. Like that. Now notice, you got to be a little careful about how you draw it around here, because we just said that it should have a horizontal tangent at x equals 0, right? Since the slope is 0 at x equals 0, it has to have a horizontal tangent there. So if you drew your curve like this, I don't know if that ever gets horizontal right there. So you got to be careful. Make sure it has one brief moment where it's flat and then it curves back up. The other one, so this is f. The other one is f prime. And that one is 3x squared. So 3x squared does this. It starts at 0. When we're at 1, it's at 3. When we're at negative 1, it's at 3. And then it just shoots way up from there. Okay. And one of the things that you're going to start practicing is looking at the graph of f and trying to figure out what the graph of f prime, what the slope function looks like. And so what you would do is you'd kind of, and this is informal, but you'd look like right here, let's say. And right here, the slope, the f prime, is pretty positive, right? It's pretty steep there. So I'm just going to do that. This is informal. Really positive, right? And then over here, it's less steep, so it's less positive, but it's still positive. And right here, f prime is 0. And then right here, if you notice, it's pretty much the same slope as this other blue line that I drew there. So here, f prime is positive. And then way up here, it's really positive. So on my graph, on the right, you know, when x is about negative 2, I should have an f prime value that's really positive, and that's what I have. When x is negative 2, it's actually way up here. It's a very positive number for f prime. When f is around negative 1, it's still positive, but it's less positive. And then right here, f prime is 0, so on my graph of f prime, I have a 0. And then it goes back up again. So here it's positive again, and here it's really positive again. And that's something we're going to start practicing more of. So let's go on to the next problem. This one's pretty simple. You know, what's the slope? Where's the slope positive? Where's it negative? Well, it's positive. Let's go. F prime x is positive. And it's definitely positive at A, and it's definitely positive at D. And if you ask me which one was steeper, I don't know, they're pretty close. But if you draw D pretty accurately and A pretty accurately, I'd say A is probably slightly steeper than D. So probably greatest at A. And then if we look at negative, so f prime x is less than 0 at, and I'd probably go with C here and F there. And I would say f is the least slope, so the most negative slope, probably least at f. And then where's it 0? Looks to me like B and E are zeros. So f prime of x equals 0 at B and E. Okay. Number 3 here. Number 3 says, from the graph of y equals sine x, determine whether, and then this notation, dy dx is positive or negative at x equals 3 pi. Justify your answer. Okay, so let's talk about that notation. You guys have seen this at some point. Delta y over delta x. That's slope of a line, right? Or it's the slope through a slope of a line through 2 points, right? This is the same thing as y2 minus y1 over x2 minus x1. That's where if you have something, you have a point here and a point here, and you draw the line through it, you can figure out this is delta y, this is delta x. Well, dy dx is very related to that. Dy dx is actually the same thing. So dy dx is the same thing as f prime x. It means what's the slope of y in terms of the x's. So like if I have a graph that looks like this, and I wanted to figure out the slope right here, remember you pick a point close to it. Well, actually, let me pick this point instead. You pick a point super close to it, and you essentially do the same process. A little tiny change in x and a little tiny change in y. And the way I like to think about it is, instead of this capital Greek D for big change in y over big change in x, it's an infinitely small change in x and an infinitely small change in y. And when you write this thing, x equals 3 pi down as a subscript after that bar, that means this, dy dx, when x equals 3 pi, that just means what's the slope of f when x is 3 pi. Okay, so we're supposed to look at the graph of sine x to figure this out. So let's graph sine x. So sine x starts at 0 and then goes up and down and up and down. And right here is pi. And right here is 2 pi. And right here is 3 pi. And you can easily tell from the graph, at 3 pi, that slope is negative. So dy dx when x equals 3 pi, that's the same thing as f prime of 3 pi. And that's going to be negative. If I said at 2 pi, well, at 2 pi, it's positive, right? If I said at pi over 2, then it's 0. Okay. Let's see here. We'll do one more, and then I'll start another video so it doesn't get too long. All right, let me shrink this down a little bit. Okay. So number 4, we're going to draw a function f that satisfies all these conditions. So first, it's got to be continuous everywhere. This part right here says it's got to go through 0, 0. F prime is positive, means slope is positive. Slope is positive on 0, 6, on that interval, which really means the same thing as f is increasing on 0, 6. F prime is negative on 6, 7 means f is decreasing on 6, 7 because the slope of f is negative. This right here says we've got horizontal tangents. At x equals 6 and x equals 7. And then this says when x is 7, y is 4. So let's do the 2 points first, 0, 0 and 7, 4. And let's see, it's got to be positive on the interval from 0 to 6. So here's 6. So I have to increase the value of the function all the way from 0 to 6. And then I have to decrease it from 6 to 7. So 7's way up here at 4. So I've got to go up past it. And then at 6, I have to turn it around and then bring it over to 7. Now, so I've taken care of this one. I've taken care of this one, taken care of this one. F prime 6, F prime 7 have to equal 0. Well, right now at 6, it looks like I've got f prime equaling 0. And then it's 7 that needs to equal 0 too. So I'm going to do something like that so it does have a slope of 0 there. So here, f prime 6 equals 0, f prime 7 equals 0. It has to be continuous everywhere, so let me just put arrows on the ends here. And then just to double check, it is continuous everywhere. I do have 0, 0. F prime is definitely positive here because the slope is positive all the way until it's 0. F prime is definitely negative here. So I've satisfied all those conditions. Okay, so I'm going to stop this video here and then continue it on part 2.